Well, hello again. I've got the old tube checker fired up as I'm letting it warm up. I want it to warm up for about, I don't know, 15 minutes or so. And this is a laboratory tube tester I've had for years. Model, it's a triplet 3444. It's tube operated. The next one they came out with, the next model, was actually underneath this panel. There's not a tube, there were a solid state device. But this has really worked well for me. And I'm going to go ahead and use it to, we'll go ahead and use it to check these 4 tubes out that came with the radio. If they're weak, I'm going to go ahead and keep them and use them. I'm not going to spend a lot of money on tubes for this cheap little old radio that we're using for this series. Remember, all we're trying to do is to get it to play. That's it. If we can get it to make sound, tune in a station, we're done. That's it. Well, so far so good on the volume control. I've got the ground wire, of course. We covered this in the last video. I have the ground wire connected to the wiper. And the 2 wires here soldered together along with a, supposed to be a 250 ohm resistor. I didn't have 250, I'm using the 240. That's going to be in series with the wires, and this end right here will be connected to this. And then we're going to go ahead and put a little heat shrink over there. I'll probably cut it down, it's a little bit too long. I want to shrink it right down, I don't want any contact. So why am I hooking up that resistor to these wires? Well, let's go back to the schematic. Inside the original volume control was a, well, it'd be 75,000 ohms from end to end. So 250, 75,000 ohms minus 250. This right here is a separate deal from this. This wiper only goes from here to here, I believe. It does not go all the way to here. And I checked with Brendan. I said, what exactly does that thing do? He said it keeps the cathode from reaching ground. So I said, okay, that's good enough for me. Well, of course, we have a brand new pot now, and we still got to come up with 250 ohms because the brand new pot doesn't have that. It's just a straight 100K. So we have to add the 250 ohms on the outside where these 2 wires connect. One from the cathode on the 6A7 and the other one from a capacitor to ground and over to our local oscillator coil. Okay, all done, insulated and everything, shrunk it down with a heat gun. And now all we have to do is hook up our antenna wire. Piece of cake, right? Where is the antenna wire? Where's the antenna wire? There is no antenna wire. What's the deal on that? The first tool we're going to check is the 80 tube rectifier. And I, take a little small brass brush, preferably brass, but I'm too lazy to go out in the cold and get a brass, so I have the steel one here. Just gently brush the tube pins. Clean any gook and crap off them you can. Don't be scrubbing them down to the nub, but just kind of brush them inside and out. Clean them up. Get any oxidation off. They'll clean up nice and easy. You don't have to go ape. And then I'm going to go ahead and stick it in the old tube tester. Nope, wrong one, John. What are you doing? Get over here. Okay, like so. And then you look in the book that came with your tube tester. And it tells you about how to check them and all this other stuff. Good information, especially on a triplet. Tells you how to check rectifiers, what they do, and what the knobs and everything does. Good stuff. And then you go to your tube chart down here. It's a roller tube chart. Try to find the 80 tube. Well, I couldn't find it. So you have to go to your supplement. You have to have these supplements on these old tube testers for these. What happened was the tube tester came out, and they created a chart for all the tubes, but then more tubes came out after that, so they had to publish a supplement. And this is the 80. Let me get my pencil here. I'm always prepared, as you can see. Get my little pencil, and I had to go to the tube supplement on page 20, and there is our 80 tube. So I'm going to set this thing up. It's a 5-volt tube. Right there's 5 volts. Now your tube testers are basically all the same as far as knobs go, setting these parameter knobs, things like that. but some tubes test better than others. This is a laboratory tube tester. Very expensive, and they sell for a lot of money on eBay. I was fortunate enough to get mine for $25, and it's been really just it was a great buy, trust me. All right, and then we're going to go ahead and we're going to go set the knob B to 10, which is this one over here. That gets set to 10. And then I have to set all these knobs according to these next set of numbers. And then I set the C knob to 6, the D to 8. I'll set that now. C to 6, this is the C to 6, and the D to 8, which is a rectifier. Okay, rectifier. Now I got to set these knobs up according to what they say. Now they say this is a 1940-2000. All right, 1940 2000. Must have messed up somewhere. 1940 2000. 1940-0200. Okay, I got it right. All right, and then we're going to go test it in a second here. Alrighty, tidy. The tube is nice and hot. Phew! It says what I'm supposed to do. Right here, you'll look on the scale on this particular one. It says rectifier OK. So there's two positions I have to test with this knob, and this knob pulled down to value. So I would pull it down to value with it in position number 1. Then I would pull it down to position number 3 and pull it down to value again. That's it. And both times the needle should go over here to where it says rectifier OK. So I'm not going to worry about this. It's just a matter of going right. I'll tell you what. We'll just leave it in position number 1 for now, and then pull the value down. Watch the needle. It should be somewhere in here. Alright, she's a little on the low side, but she'll be fine. Now, it says I have to move it to number 3 and do the same thing. And I just use both fingers and pull them both down at the same time. Here we go. Oh, that's a little stronger there. Okay, the rectifier is good. That's what I'm going to do for the next tubes. Each one has a different setting. Each one has a different pull-down switch, and whatever it says on the chart here or on the supplement is what we'll do. Alright, the next tube, I'm going to do one more because I want to show you the difference between 1 or 2 tubes. This one's a 42. Where did it go? Here it is here. This is a 42, goes in the same socket up here as the rectifier went in, only it takes different holes in there. Get it down in there. Try it. It's already lighting up. That's good. I like that. Okay. I already cleaned the pins with the wire brush. Now, according to this chart here, see, now the rectifier had a 5-volt filament right here. I've got it set to 5 volts. But when you look at the 42 on the next chart, that's why these supplements are so important. The 42 it says 6.3 volts. See it? So we're going to flip this up one more switch. Boom! 6.3 volts. Uh-oh, I broke my heater. No. Alright, then we're just going to go across and set the switches just like you saw with the 80 tube. No sense in going through that again. I just wanted you to know that there is different. And by the way, when you're all done, I had a tube one time that I can't remember what it was. I had to set the filament voltage way up over here, and I forgot to set it back to 0 or back to off when I got done. So I stuck the next tube in there, and when I did, it was like a 6-volt filament. Just fried it just like that. Brendan wasn't too happy over that, and neither was I. I did, but you know, these mistakes are made. You get in a hurry sometimes, you know. It's just things you got to live with. You don't cry and whine and snivel about it. You just say, well, lesson learned. You know, that's right. All right, our 42 tube should read on the second scale here 1.3 to 2.5, so it should be read somewhere in here like that. This is only a one knob pull at the bottom. Just this one is all it takes, down to value. Well, that's a strong tube. It's a very strong tube. I can live with that. I'll show you one more thing. When the tubes go in there and everything's hooked up. Now this one happens to be, this is a 6A7, happens to be a grid cap. Okay? Some have a plate cap. You got to look at your chart. And in this case it says number 7. You make that 7 out there. Number 7. And you look down here, and number 7, it says it's a grid cap, okay? Had it been a 6, it would have been a plate cap, but it says plate cap, but it's a grid cap. And there's a shortage leakage switch on this thing too. It starts out with the value for you to check the strength of the tube, like I've been showing you with the needle. But you can also cycle it through the positions all the way here to the heater and cathode to make sure there's no shorts. So we'll go ahead and take a look at our scale, flip it around. Nothing. That's good. Now we'll go ahead and let it warm up a few more minutes, a few more seconds, and then I'll go ahead and pull the old switch, see what the value is. Alright, it's supposed to be reading the second scale again, 0.8 to 1.6 in this area here. Let's see. Now there's such a thing as the tube being too strong. If this thing were to peg way out over here, that's way above tolerance, so that tube's no good either. It's got to, you know, be within the bottom and upper numerical scale that's determined on the chart or in the supplement. So let's see what happens. I'm looking for 0.8 to 1.6. Look at that. Boy, I'll tell you what, that's a strong tube right there. Very strong tube. One more thing I want to pass along. I don't want to drag this out, but this is important. If you ever get a tube tester, some of you will, make sure you, when you have a grid cap, that sort of thing, make sure you clean the wire brush to get the grid cap or the cap of the tube. It could be the plate or the grid. Wire brush the cap too. Make it nice and shiny so when you connect your wire on, you have good contact, okay? Anything that deals with these old tube radios has to have shiny, good contact. If you contact anything on it, no matter what it is, and it's tarnished and screwed up and it doesn't look good, you're not going to have good contact, whether it be a ground, a tube connection, a tube pin, a solder joint, any of that stuff, any of your switches, you know, your wafer switches for your shortwave to broadcast band, anything like that. While testing the tubes, I realized that this tube base is loose from this rectifier. That's why it's always important when you pull these tubes out, if you can get a hold of the base and pull them out like that, wriggle them back and forth and pull them out like that. Don't be grabbing them like this and doing this kind of crap, because it pulls the wires right loose from the pins or separates the glass from the plastic. So whenever you have something like that and you notice it's loose, stop. Don't go any further until you fix it. Otherwise, if you just keep doing it, you're going to wind up breaking the tube, and then right in the middle of your troubleshooting or restoration or whatever thing, you're going to have to delay because you got to order a new tube and it's going to cost you money, where all you got to do is put a slight bead of super glue around there. Just a very slight bead all the way around it. Doesn't have to be a whole lot. That'll hold it in place. Now you can get a super glue that's made for glass. That's right. And it'll cling to glass real good and seep down in there, and just kind of hold it up there like that until it dries, or put it in some kind of a deal where it'll stay in, you know, up like that until it dries. Not like that. Let's go over all the components on the top of this radio, and then underneath, a few underneath as well. For those of you who may not be familiar with this stuff, you know, maybe the first time you saw it, you only know one or two parts. I don't know, whatever the case might be. Keep in mind, this entire series is geared toward newbies. All you guys that know all this stuff, you know, bow out. Let the newbies get a chance to learn all this stuff so someday they can know all about it. This is the power transformer. It's a step up and step down. Well, how can it be a step up and step down? Well, it takes 100. My house, I think, it has 126 volts coming in, and this is a new power cord, by the way. Somebody put that on there in the past. Anyway, it takes 126, whatever your house might be, coming out of the wall, and it steps it up. In this radio, if you go to the schematic, you see that the tubes, the maximum voltage needed to operate the tubes is 215 volts. So I don't know what the output for this thing would be. The electrolytic filter capacitors are rated at 450, which somebody put in there, and I'll show you that later. So I don't know. They don't run these things right at the limit, you know, 215 volts. It would probably be somewhere around 300 volt output, 275 output, I don't know. As long as it's putting out voltage and the tubes are functioning, that's all I care about, you know. And that's the step up portion from 120 to 215, at least 215. The step down is the 120 coming in. It steps the voltage down to 6.3 volts to operate the tube filaments. So that's how, and it has to do with the windings on the secondary side of the transformer. The more windings, the higher the voltage. The fewer the windings, the lower the voltage. So that's all you really need to know about that. We have our speaker, of course. You already saw that. The speaker and the speaker cone. The thing that holds the speaker cone is the speaker basket. That's this thing right here. Holds the speaker basket. This thing is usually attached to the speaker. Not always, though. Sometimes it's on the chassis, depending on the size of the radio, how much room, whatever the designers did. Don't ever take anything for granted on these things as far as design goes. Each manufacturer had its own way of doing things. If you don't believe me, when you get more experience in this stuff, start looking at Atwater Kent chassis, and you'll find out how each one had their own way of doing things. Old Atwater Kent, Arthur Atwater Kent was his name. He had his own color code for resistors. He's a pretty stubborn old fart. Anyway, this is the audio output transformer that links the output tube to the speaker. That's right. This is the go-between. Right? It matches the speaker to the output tube. If the output tube drives too hot and too heavy, it'll burn out. So this thing kind of, you know, culls it back. I should mention that the name of that reverse resistance is, you've got your DC resistance, which is, you know, just the coil windings. You take a multimeter, measure the resistance. That's DC resistance. The impedance, everyone has a different impedance, and it's matched up to the tube. Impedance means just that. It impedes the flow, and helps keep the tube within parameters. This thing right here is a field coil. They came out later on with just permanent magnet speakers. This thing here is a field coil. If you don't get, it generates the magnetism necessary to operate the speaker. If the field coil burns out, you're out of luck. Now, you're out of luck with this speaker here, but you can convert these things to a permanent magnet. I've done that a couple of times already. It's really easier than I thought. And then, of course, we have our tube sockets, and we have an IF transformer. IF stands for intermediate frequency, and this thing is basically just a small transformer inside of the can with two adjustments on the top. There's going to be a lot of luck. I don't even know if these things would even adjust, or they're so rusted up and everything. I've torn these things apart. I remember when I first started out doing radios, I was on the Antique Radio Forum, and I was restoring a radio, and I told them I was going to take this can apart and make sure the coil was good and whatever else. And, oh my God, don't do that. No, leave the can alone. Stay away from it. Don't touch. See, what are you talking about? What do you mean stay away from it? Don't open it. Yeah, apparently it had never been done on the forum, or no one had ever seen it done with photographs and everything. I'm sure guys had done it, but for the most part, they thought I should not touch that can. There was a couple of them in that radio. Sometimes you had three, depending on the size of the chassis, how many tubes and all that sort of rot. There again, the design of the chassis by the manufacturer, the engineers. Anyway, I went ahead and tore it apart, and everybody went, "Oh, that was a good idea. I learned a lot I didn't know." You know, so I wanted to know what was in there. This is my radio. I was learning what was inside these cans. I wanted to see what was there, and no one was going to stop me. Okay. This is your tuner, or your variable capacitor. It's a series of plates. Keep in mind, a capacitor is two conductive surfaces separated by a non-conductor, and that non-conductor can be air. Alright, here you can see the plates of the, let me get this wire out of the way. Here you can see the plates of the variable capacitor. Each one of these is a conductor. They're paired up and they're separated by a non-conductor, which is the air. Okay? You've got one for the antenna and one for the oscillator. Okay? Sometimes you have 3 or more. I think I've seen even 4 of them in the large, really big radios. Okay, variable. It's a capacitor. Each one of those is a capacitor. It's just variable. That's all. Or in short, it's a tuner. That's what tunes your radio in. This up here, these are the little capacitors on top of the tuner with adjustment screws. You know, when the thing gets out of alignment, and you can put a screwdriver in there, and using test equipment, you can, or by ear. In this case, this radio is so small, you can do it by ear. Just kind of tune in the stations, fine tune them, tweak them up. Keep in mind, this is just you know, applicable to this particular chassis now. Okay, every chassis is different. Some of them are so busy you can't even find stuff in there. There's so many wires. Philco's really good at that. RCA is pretty good too. Anyway, here are your filter capacitors. Now these are rated at, remember I told you, the maximum the tubes needed per the schematic is 215 volts. And that's plate and the screen grid and the plates are 214. So that's kind of strange. Anyway, these are rated at 450 because they've been replaced. You can always go above the rated value of the voltage. It means you can just take a lot more voltage before it goes kaboom. But you don't want to be going underneath the voltage, okay? Don't do that. And you don't want to be go underneath the value needed to filter the voltage coming in. Now, you get a chassis, you have turned it on maybe, and you want to make sure it's, you know, you've unplugged it and everything, but the capacitors do stay charged up. Well, how do we uncharge them? You want to be on the safe side. I keep stressing safety, safety, safety. And Brendan wanted me to stress the fact, again, that just because this thing has a transformer on it doesn't mean that it's not, that it's safe. You know, of course not. Common sense tells you it is not safe. These are old radios, people. You never know what you're going to find in them. You don't know who's messed with them before. Some guy may have hooked something up to the wrong place. You know, some whiz kid who thought that, well, if I do this, I'll get better filtering, or you know, and in the end they screw it up so bad they can't even remember how to put it back. You know, back in the old days, these, you know, Uncle Billy, the local family electronics technician, he took 4 courses from the National Radio Institute. Man, he know. I mean, he just took 4 of the lessons, and he knows this stuff now. He doesn't even have to finish the course. Oh, okay, fine. He'd be able to fix somebody's, you know, radio. And he was the genius. Oh, take this to Uncle Billy. He knows all that stuff. Anyway, let me show you how to discharge a capacitor if you're ever concerned about it, and you should be concerned. I don't have any problem with that. Now, these things are labeled. See this right here? Let me zoom in here. See that positive sign right there? Right there? That's the positive side, okay? So what you can do is hook up a, you know, a alligator clip to the now the positive side of these 2 sets are connected together. Both of them connected together, so it's going to be easy. You discharge 1 or 2, you discharge all 4. Put your alligator clip on the wire like that. Take the other side, hook it to a small screwdriver or something metal that's got an insulated handle on it. Then just touch the chassis. Okay? That's all you got to do. And it'll discharge through the wire, through the screwdriver, to the chassis, and you're safe. You're good to go. And lay it on there as long as you want until you feel, you know, comfortable. Now, another way to do this, you know, if you don't have an alligator clip, is you can just take your screwdriver, touch it here to the positive side, and do it like this. Okay? Keep it on there and discharge it down. Now, if you have capacitors that are not connected together, you know, like these are, you might have a couple over here, a couple here. Well, do the same thing, only just do it on both sides. That's all. You know, just go ahead and do it to the positive. One other way you can do it is taking it from the negative to the positive, like so. Just let it set, and they'll equalize out, and you won't have any more charged up capacitors. I don't particularly like this way, you know, because in the process of hooking it up, you can get a big spark out of there. Pop! Just scare you half to death, you know. Don't do that, okay? Just hook up the positive and then hit it to the chassis with a screwdriver. You may still get a pop, but it won't bother you so much. Okay, what else we got here? We got to start wrapping up this video. It's getting a little long. This is your, in this particular radio, this is your antenna coil right here, this big sucker. These are wax capacitors. These are what's called dog bone resistors. They look like a little dog bone. Yeah, you know, that's the term we got. And then you have these types of resistors here. I don't know what they call them. There's a name for them. I don't really care what they call them. I just know what they are. And these here are called your mica capacitors. Okay. And another wax capacitor over here. Now we have to find the oscillator, the local oscillator coil. Where is the local oscillator coil? Anybody see it? I see it. I know where it's at. It's under that square thing. Let me show you. There it is. There's the little coil down there. Let me get this where I can focus in a little bit. There you go. That's the oscillator coil right there. It's pretty small, isn't it? It's mounted to this right here. One more thing about this volume control. Normally volume control is over here in the audio section. Turns the volume up and down from this area. This one here is instead, see, this is controlling the voltage up and down. That winds up out here at the speaker, the output tube in the speaker. But over here, this is the first time I've seen a radio with a volume control in the antenna section. But what it's doing here is it's increasing and decreasing the signal coming in that ultimately winds up at the cathode of the first tube right here, the 6A7. And the question is, why is it not over here in the audio section? Why is it over here in the antenna section? There's a reason for that. I just want you to know that sometime in in the future, if you stick with this sort of thing, you may run into a volume control in the antenna section. And I'm not going to go into. There's a reason for it, and I'm not going to go into it because it's beyond the scope of this series. I just want you to be familiar with it. I had never seen one until this radio. The last thing we're going to do is hook up that missing antenna wire, and then we can call this video quits. Now we have this part right here. Now you notice there's a black dot right there. Can you see it? That's a connection point, okay? We have this part right here. The part we're missing is this wire here. Now when I said we have that part, this is it right here. We have this part, okay? It goes through the chassis and it hooks to the antenna coil right there. And as you can see, this thing has had somebody messing with it. Alright, the wire I'm going to connect there is going to be this white one. I just cut it a little bit long. I'll strip it and solder it in. We're going to solder it right there. Then we're going to run it up through the chassis hole and hook it to the volume control. Let's get that done. Well, there's our bottom connection to the coil. Well, there it is, soldered to the volume control. And of course we clean our solder joints with alcohol and an acid brush. Get that flux and crap off of there, make it nice and shiny. And that part of our little project is done. What's on the agenda for next time? Well, it's this wire right here. This is the last of the Mohegans. We get that thing connected up to where it's supposed to go. I got to remove this audio output transformer so I can see where it actually is going under there. I can't see. It's so tightly packed in. Don't want to make a mistake now, but it looks like it might be, I don't know, it looks like it might be the field coil. I don't know. Anyway, we're going to go ahead and square that away, and then once we're done with that, we'll clean a few of these connectors that go on top of the tubes on the control grids. We got one here, we got one here. We're going to clean them up real nice, get them shiny so we get a good hookup. And once that's done, we'll do what they call, the first time I ever heard this was some young guy, modern type of young guy. We're going to populate the chassis with the tubes. No, we're not. We're going to put the tubes in the sockets That's how it's done in my day. Anyway, then we'll fire it up, put some power to it, and see if we get some noise. Hooks up the antenna. Until next time, this is John.